Hey folks, Raph from Defang here, and today I'm going to show you the fastest, easiest way to get a Django app up and running in the cloud. I wanted to try windsurf, and I wanted to give this a sort of vibe coding attempt, somewhere between vibe coding and, using the 10 years of building Django apps that I've done and mashing those two things together. So I just kind of told it to create a Django app that runs in a Docker Compose, a production one and in compose.yaml, and a dev one in compose.dev.yaml. That's usually how we structure apps with Defang. So it actually did a pretty good job, but we do need to make a few tweaks. And basically, what I built today is this chat app with real-time auto moderation. So multiple users can interact with it, and there's a background process that runs in a worker environment that will monitor each message as it comes in and use the natural language toolkit to process the messages, do a sentiment analysis, and check if there's any profanity, and basically automatically moderate any messages. But another use case that you could imagine with something like this is maybe you want an AI to respond to messages. You could do a wide variety of sort of processing on the messages that you don't want in your main API. You want these offloaded to separate containers in this case. So let's take a look at it. So this is the web app. This is the worker app. So it's all of the code is in here. Just one in this worker service and the other one in this web service. We've got a database using Postgres. We've got this xDefang Postgres extension, which tells Defang when you're ready to deploy to your own cloud environment to provision a managed database. So for example, in AWS, that would provision an RDS instance. And then we've got the broker. So we're using Redis as a broker. And same sort of thing, we're doing xDefang Redis to tell Defang provision a managed Redis instance. And so yeah, basically it's these four services. Let's get it up and running locally. Okay, so to get things up and running locally, we're going to do this. Docker Compose, we're going to use this environment file with these environment variable values that will replicate the experience in the cloud as well, which we'll talk about soon. We're going to use this compose.dev.yaml, where we basically extend the production file and then just override certain values. You can see I've already run it before, so it gets up and running nice and fast. And if I head to my browser, localhost 8000, you'll see we have an app. And so we can set up a room, my chat room. It'll prompt you to register, user 1. No. Okay, my chat room. Sure. Cool. Hi, folks. So there it is. I can do the same in here. User 2. Hey, how are you? So we're using Django Channels. We're using Redis as a broker for that live interaction. We're also using Redis as a broker for our queue. So let's say I'm kind of a jerk to user 2. User 2, you are awful and nobody likes you. So you can see this gets flagged and automatically hidden. Technically, you could do stuff that actually takes a little bit longer. You could, I don't know, do whatever you want here. But the thing that's cool is you can see that that is running on a separate service. So a separate machine, you can have long-running tasks, compute-intensive tasks that you can offload there and make sure that your main API stays nice and snappy. So yeah, basically that is what we are going to deploy today. You can see that the app itself is pretty straightforward. Windsurf did a pretty good job of just setting up a couple models. So we've got a room model and we've got a message model. It just has some content and the user who wrote the message and then some moderation fields, which we automatically fill in using this task over here. So we're using NLTK to process these things. And essentially what we're doing is, you can see here, we get the message content. So we check for profanity. And then we do some sentiment analysis. So if we see profanity, we flag it. And if we see that the polarity is lower than -1, so it's kind of a negative message, and the subjectivity is very high, so something very personal and negative, then that's what we're going to flag as a potentially negative or unfriendly message. Now, these values are kind of low. You would, of course, like tweak these based off your use case. I set them low just so we can easily show something here. You would probably want to do something a bit more complicated in this. And I think this is kind of a neat use case for this particular architecture because you can imagine doing a lot of other stuff with NLTK or maybe some machine learning tools to sort of auto-moderate a chat room like this. And that might be more compute-intensive work that you don't want in your main API servers. So you want to offload that with a queue. And what's kind of neat here is because we're using Redis as this broker for WebSockets for the real-time stuff with Django Channels, directly from this service, we can send this back to the browser through Redis, through Django Channels, and back to the browser without having to do any sort of polling or reloading of the web page. We just automatically get this as soon as the processing is complete. Okay, so that's this app. And I kind of wanted to show you like a pretty full-featured Django application. So with a couple models that runs on different servers in different contexts, uses Celery for task processing, we use channels for real-time. You'll notice one other thing. So if I go to localhost 8000 admin, now I can just do admin, and I can go check out messages. And so it's a full-featured app. Like we've got admin views set up. We've got these relatively complex systems with queues and WebSockets and all of these things. So deploying this, if you wanted to deploy this to the cloud, you'd have to provision all of these different things in AWS or GCP or DigitalOcean. All of them support Redis and Postgres and allow you to run containers in different ways. But it's a fair bit of stuff to replicate. So if you're like me, you love using Docker Compose locally because it allows you to sort of replicate that sort of structure, right? Like that you can say, well, I've got 3 databases and 2 different Redis instances or whatever for whatever use case. Or in this case, database, Redis instance, worker, and they all run sort of logically as these different services. But doing that in the cloud, provision ECS clusters, you've got to set up networking, security groups to make sure that you can connect properly to your RDS instance or whatever. All of these things become really complicated, and that is where Defang comes in. And this is what I think is kind of magic. I mean, I'm a little biased, but basically pretty much most things should just work. So what we do, and I'll go into Playground here, is we'll do something like defang config set, and then Django secret key. And then you're going to get a secret key and put it in there. So Django secret key, I don't know, we can put in whatever we want here. I've actually already done this, so I'll leave that. but you would do the same for your Postgres password. So defang config set Postgres password, and then you can set those values. And once you've done this, Defang will automatically fill those in when you do Defang Compose up. So if I do that, you can see that it is basically doing the same thing that Docker Compose does, right? So it is going to run a build of your containers, but instead of just running them locally, it's actually going to spin up containers in our Playground environment. And our Playground environment is basically just a cloud environment that runs containers in our own cloud accounts. So you can see what it's like to get things up and running. But of course, the magic of Defang is that you can take this to your own cloud accounts. So if you have your own AWS account, your own GCP account, DigitalOcean, we've got different support for different features across different clouds, but we are working hard to get them to parity so that you can just take any Docker Compose file to any cloud and get things up and running. So you can see here, our web instance is applying migrations. Our worker is downloading the NLTK data it needs. I think our database is already good to go. Our Redis instance is good to go. And if we head over here to the Defang Portal, you can see these things happening. So that's portal.defang.io. And you can see as the services deploy, so you can go in and you can see the logs here. When everything is ready, these things will turn green. Basically, they all need to just get through their health checks. And once that happens, we'll know that they're good to go. All right, look at all those lovely green circles. So let's check out our web instance. And what we've got here is a publicly accessible URL that we can click on. And I can add my test room, create room, register, user 1. Oh, don't save that. Test room. Cool. Hello, friends. It does sometimes take a little bit longer the first time. What's up? There we go. That's nice and fast. And I can do the same thing as I did locally. So if I go here, let's log in as user 2. And you're a bad person and nobody likes you. That's kind of mean. Right, there we go. Flagged as negative or unfriendly. You can see some details here. So that is our app deployed to the cloud pretty quickly with Redis, Postgres, a web service, so worker service, all of this stuff up and running in the cloud very quickly. And if you've ever tried to set this up yourself, you know that setting up networking so that you can point to each of your services the same way that you can in Docker Compose is a huge pain. So I just want to point out that we connect to our database using DB as the host name. So you can see that over here. We've got DB to connect to DB. We're using broker to connect to broker. And all of this stuff just works because we provision all of the networking infrastructure. We make sure that your things are secure. It all just is ready to go, which I think is pretty sweet. But let's take it one step further. Let's say you want to deploy this to your own AWS account. So what we're going to do, I'm logged into an AWS account, but I'm going to do export Defang provider equals AWS. And I already have an AWS profile. So export AWS profile, but oops, not, well, profile written properly. So I already have that set up to deploy to an AWS account that I've got. And I'm going to do Defang Compose. Actually, let's do Defang config. Config ls. So you can see here it's saying using AWS provider from environment variable. That's because we did that Defang provider environment variable. So you can see I've already set these values. And similar to Playground, I can just do Defang Compose up. And it is going to deploy this stuff to my AWS account. And all of this will run in my AWS account. So it'll upload all of the necessary files and it'll run container builds as if you're doing Docker Compose build or Docker Compose up -- build. All of that just runs in your account. It doesn't rely on Defang infrastructure. So it's all nicely self-contained, which can be nice if you don't want third-party dependencies tied into your infrastructure. So you just have the one cloud account and it all just works. One thing that I will point out, when we deployed to the Playground, this got up and running pretty fast. And part of the reason for that is we are just running a normal Redis and Postgres container here. But because we've got these x defang Postgres true and x defang Redis true extensions in our compose file, what's going to happen in our AWS account is that we're going to provision managed services. So we're going to provision ElastiCache instance in AWS and an RDS instance in AWS so that you have backups, that you have all of the guarantees that come with running your Postgres and Redis instances in an environment that is managed by your cloud provider. But what that requires is for AWS to actually provision those instances, and that can take a while. So I've actually already run this so that we can cut down the time required. But normally AWS can take 5-10 minutes to provision those instances. And so just be aware of that. We cannot speed AWS up. That is just a constraint of using a managed service. It's got plenty of benefits, but the initial provisioning time is one of the cons. So we can see some stuff happening in here. Web, running migrations, no migrations to apply because we have already applied them. You can see these health checks are coming through. Okay, so I paused and let this get through a couple health checks, but you can see here, eventually what happens is once these services are marked as healthy, then Defang's CLI will disconnect, and you will see these messages, which tell you that everything is completed and will give you the address for your app. So if I go here, test room, create room, user 1. Whoops, no, gotta register first. Alrighty. Hey folks. That first connection is always a little bit slow. You're really awful. Your face is bad. I don't like you. So there we go. That is up and running in our own cloud infrastructure. Let's take a quick look. I just want to show you what that actually means. Okay, so you can see here, I've got Defang Django Chat demo beta cluster. And in here, we've got my two services, the web service, the worker service. If I click here, configuration networking, you can see that we're hooked up to a load balancer. And we'll go check out RDS. So in RDS, here's my database, nicely provisioned and properly networked. Let's go check out ElastiCache. So here is our Redis cache, and also nicely configured so that we can just connect to it directly from our services in our ECS cluster. And yeah, that's basically it. There's a whole bunch of other stuff that you can do. You can add your own domain and we'll help you manage SSL certificates and a whole bunch of other stuff. But yeah, I hope you enjoyed this. I think it's the easiest way to get Django up and running in your own cloud. So hopefully you give it a shot. Let us know how it works for you. All of the code will be published on GitHub. I will link that in the comments or in the description or wherever, somewhere. We'll make sure that you can find all of the code. Thanks, and I will see you in the next one. See you, folks.